In this video, I will review a variety of relationships between the angles and arcs on a circle, and also between the different kinds of segments that are formed when we have intersecting lines with circles. So before we begin, please understand that you need to memorize these four formulas relating angles and arcs, depending on whether the vertex is at the center of the circle, or if the vertex is on the circle, or just somewhere randomly inside the circle or outside the circle. These formulas will not be given to you, so you need to memorize them. So this says angle equals arc divided by 2, angle equals arc plus arc divided by 2, and angle equals big arc minus small arc divided by 2. So for the first problem, we see that all of the angles are at the center of the circle. So that means we're in the situation where the angle and the intercepted arc will be equal. So keep that in mind. We need to find the measure of arc FE. Okay, so arc FE is going to be this arc right here. All right, here comes arc FE. But arc FE is the intercepted arc of this angle right here. And these are vertical angles. So if this is 130, then that means this is 130. And at the center, the angle and the arc are the same. So if this is 130, that means that the arc is also 130. So that's why this first answer is 130 degrees. Next, we need to find the measure of arc BFE. Okay, BFE. All right, well, that's kind of overlapping, so I'm going to use a highlighter. BFE is all of this yellow right here. Hopefully you're noticing that segment BE is a diameter, which makes the yellow arc a semicircle. So we know that arc BFE is going to be 180 degrees. How about arc FBE? All right, FBE is this arc that goes the long way around the circle like this. FB until we get to E. So this is the entire circle except for 130. So I should be able to subtract from 360. So 360 minus 130. So that is 230. So that is the measure of the yellow arc. Okay, what about arc CD? Okay, arc CD is this purple arc right here. That is what we're looking for. But actually, first, maybe I'll just go ahead and extend this on. Let's find this purple arc right here first. Remember the diameter. Remember that we have a diameter right here. That means we have a semicircle going on right here. So this yellow is 180 degrees. So we already know that this part of the circle is 130. All right, because the angle is 130. So we should be able to easily find this purple part by subtracting from 180, all right? It's a semicircle. So 180 minus 130 is going to be 50. However, so that is arc CE, but CD is going to be half of that. So this will be 25 and 25. Because of the markings that show that these are congruent, that's how we know to split it exactly in half. So arc CD will be 25 degrees. Okay, how about arc BD? So arc BD goes like this. All right, there's arc BD. Well, that's going to be 130 plus the extra 25. So that's going to be 155. What about the measure of angle DAF? Let's see, DAF. So angle DAF is this blue angle right here. So we can see that that is made up of 130 plus the extra 25. So that's going to be 155 again. All right, let's move on. Okay, I need to erase this. Is in my way. Okay. The first thing that jumps out at me before we even get started. When you see a triangle that is sitting on a diameter like this, we automatically know that this is going to be a 90-degree angle. This is going to be a right triangle. All right, and really that's because of the diameter, that makes this a semicircle. So that's 180, and this angle, an angle on the circle, is half the arc. Half of 180 is 90. All right, but I really want you to memorize. If you see a triangle that's touching the circle and sitting on a diameter, it's a right triangle every single time. Okay, well, let's see what they're actually asking us to find. Angle CDB. Oh, okay, that's 90 degrees. Okay, that's what we just spoke of. Now, how about arc BD? Well, when the angle is on the circle, when the vertex is on the circle, that's when the angle is half the arc. Or you could say that the arc is double the angle. All right, that would be another way of saying the same thing. Double the angle will give you the arc. It goes both ways. But in this case, we need to double the angle in order to get this arc. Okay, so if I double 28, that's going to give me 56. All right, so this is 56. Finally, we're supposed to find arc CD, which is right here. But this is a semicircle, so I can subtract from 180. So that's 124. For this one, we've learned that when you have a quadrilateral inscribed in a circle, do you remember the theorem that applies to this situation? All right, here's what it is. When you have a quadrilateral in a circle, we learn that opposite angles are supplementary. That's what we're going to be using right now. Okay, so that means, for example, the 106, angle B and angle D, those are supplementary. So if angle B is 106, what's angle D going to be? It's going to be 74. Okay, so that's going to be 74. So let's see. Next, they want to know what the measured angle, arc BCD is. Okay, BCD goes around like this. All right, so I'm going to have to do this in 2 steps. They gave us this angle that I'm going to show in green. All right, they gave us this 78. Now, that 78, the intercepted arc is this angle that I'm putting in blue right now. So, Alex, can you tell me the relationship between the green angle and the blue arc that I just drew? That's right. The angle is half of the arc. So that means the arc is going to be double the angle. So, of course, if I take 78 and I double it, okay, that's 156. So that tells me that this big blue angle I just drew is 156, the whole thing. Okay? But I need to know this part that I just put in red, that part of the blue. So what's that going to be? So that part is going to be 56. Since the whole arc is 156, one part of it is 100, the other part will be 56. Okay? So that's the key that we needed to finally be able to answer this question. Get rid of this. Okay, so now, arc BCD. Okay, actually, I guess we answered both questions. So BCD was the blue angle that we found, the blue arc that we found in the first place. So that was the 156 that we found right away. Okay, by doubling the 78. But then we've already answered arc BC, that's 56. All right, let's see what's going on with this one. All right, I see the arcs that they gave us. One thing I always will look for before I even get started is a diameter. I love to see a diameter. For example, you can tell that this is a diameter because it goes through the center. I love the diameter because semicircles, right? So how many degrees do I have like right there?
180.
That's 180. So how many degrees is this right here?
49.
Okay, so that's going to be 49, and that's one of the things we were asked to find. Okay, so that was half the battle. Now angle DFE. All right, so I'm going to put a little X right there. So it's a matter of which formula we're going to use. So when we're inside the circle like this, can you tell me, all of these formulas start off angle equals. All right, well, what's the rest of it?
Arc.
Correct. It's going to be arc plus arc divided by 2. So what goes in the front of the equation? But which one? Like, what's the angle? X, okay? So I put the X where it says angle. And then, what are the 2 arcs? Okay, so that's close. The thing is, see this hourglass shape where the angle is? The 2 arcs have to be the arcs that are on either side of that hourglass. Okay? So what are the 2 angles? So what are the 2 arcs we have to use? We have to use the 93 and the 49. Okay? So it's going to be 49 plus 93 divided by 2. And then go ahead and tell me what that is when you have it. 71. Okay, so we have 71 degrees. All right, and then they say angle DFC. Okay, so angle DFC is this angle that I'm sort of putting in blue. And considering the fact that it's right next to this angle that's in yellow, how am I going to find, if I know the yellow angle, how can I find the blue angle? Jump in, Lauren, if you have an idea. No? You're not sure? Okay, so this was back really from a previous unit, but can you see that the yellow and the blue, that's a straight angle. See how they're side by, so 180, 180. So if the x there is 71, then how will I find the other one? Exactly. So if we do 180 minus 71, so what's that going to be? 109. All right. Does that make sense? All right, for this problem, we need to find the measure of arc BED. Arc BED is this arc right here. But it seems to me that this is the rest of the circle, except for two arcs that I already know, 92 and 72. So I should be able to subtract from 360 to find this purpleness. So I'm going to do 360 minus 92 minus 72. That is 196. Okay, so the purple is 196. Now, what about the measure of arc BE? Well, we see that we have these two parts marked congruent. So that means that arc BE is going to be exactly half of this. So I'm just going to take 196 and divide by 2. So that's 98. All right, now, what about the measure of angle F? Well, we have learned that when you have an angle with the vertex outside the circle, the formula goes like this. Angle equals big arc minus small arc divided by 2. So I'm going to put a little x in here to show that this is the angle F that we're looking for. So the angle is x, so I'm going to put x equals. The big arc is 196 minus the small arc, which is the 72, divided by 2. And so I'm just going to put that in my calculator. So 196 minus 72 divided by 2. So that is 62. On this problem, they are asking us for a whole bunch of things, but they gave us a hint that it's probably going to be easiest to find everything in the order that it was given. So we'll start with finding arc BC. So I'm noticing, so here's arc BC right here. Now I'm noticing that that is the intercepted arc of this green angle right here. Now, since this angle is on the circle, also known as an inscribed angle, the angle is half the arc, or the arc is double the angle. So that tells me that this arc is going to be 80. All right, so I know that that's going to be 80. Next, they ask us to find arc CD. Okay. Hey, tell me again which one you were looking for, so I'll remember when I get to it. Angle CFD. Okay, that's my ultimate target. All right. So for now, they're asking me to find arc CD. For arc CD, I'm going to use the diameter. I love it when I have a diameter because that tells me I'm going to have 180 degrees. So up here I have the semicircle happening, right, because this is 180 degrees. And oh, these calculations are easy. Since this is 80, then that tells me that arc CD is going to be 100. All right, so that's going to be 100 degrees. All right, next, I'm supposed to find the measure of angle D. All right, well, angle D is the angle that goes with 80. It is on the circle. It should be half of the arc. So that tells me that angle D should be 40 degrees. Okay. All right. I don't think I'm going to need that again. Next, I'm supposed to find the measure of angle CAD. All right. Angle CAD is this angle right here. CAD. This is a central angle, so that's going to be the same as the arc. So this angle should be 100 also. So CAD is going to be 100. Okay, so that brings us to our real target, CFD. Okay. Erase this for now. So angle CFD is like this. All right, that angle is not on the circle. It's not at the center of the circle. It's just floating around inside the circle, okay? So that reminds me of the rule. What is the formula for when we're looking for an angle with a vertex that's just floating randomly inside the circle? What's the rule? Exactly. Okay. And I always like to say angle equals in front of that. So angle equals arc plus arc divided by 2. All right. This is the formula that we use for when we are inside the circle, but not at the very center. So we know the formula is arc plus arc. That's why I made a big X out of it instead of just leaving it angle CFD. I made the giant X so I could get both arcs that I need. So looking at the ends of the X, I see the arcs that I need are the ones that I'm putting in blue right now. All right, those are the arcs that go with this pair of angles. Okay, I'm going to undo that for now. So that's so angle equals. So what are the two arcs I'm talking about? 163. All right, so we're just doing 163 divided by 2. What does that turn out to be? 81.5. Okay, so I know that was your question, but I'll go ahead and just finish this in case anybody else needs it. So next we're supposed to find the measure of arc ED. Well, arc ED, erase this for a second. Arc ED is right here in green. Now, I'm noticing that we have the rest of the entire circle. All right, we have the black, the red, the purple. We have everything except for the green. So I should be able to subtract. Oh, you know what? That was dumb. So what would be quicker? I've got a diameter happening here, which means that this is a semicircle over here. So it'll be quicker just to subtract 63 from 180. Dylan, you're spacing out. Get back to work. So I'm just going to do 180 minus 63. That's the quickest. So that's 117. All right, 117. All right, next we need to find the measure of arc BDC. Okay, BDC. All right, so that's going to be the long way that goes like this. B to D. By the way, so far I've gone 180. This is a semicircle. So I'm going to go 180 plus an extra 100. So that's going to be 280. Okay, and finally, we need the measure of angle G. Angle G is outside the circle. And the formula for when we are outside the circle is angle equals big arc minus the small arc divided by 2. Okay, so the angle should equal, all right, so let's be careful. Notice that the angle touches the circle here at B and C. So the small arc is just going to be the 80, but the big arc goes all the way around the circle like this. Okay, that's actually the other arc, that huge, huge arc. So I could add up 63 and 117 and 100, but it would probably be quicker just to subtract the 80 from 360, which you should be able to do in your head, but I'm going to show it. That's 280. All right, so this large blue arc is 280. So that's the big arc and the small arc that we're talking about. So this will be 280 minus 80 divided by 2. So that's just going to be 200 divided by 2, which of course is 100.